Assalamualaikum and hi everyone. Galvanic cell part 3. So you are going to learn about definition of electrode potential, define standard reduction or electrode potential E0, and define standard cell potential E0 cell.
Let us consider the following situation. Miss Kemp wants to measure the height of her students. There are 3 of them, Azmi, Lunsin, and Chandran. Since Chandran has an average height, she asks Chandran to come up to the height board. The height of Chandran is marked on the height board with the label reference. Then she asks Azmi to come up to the board and mark his height with a line labeled with his name. The difference in Azmi's height from the reference is calculated and it is marked as positive X units. After that, she asks Bunsin to mark his height on the board with a line labeled with his name. The difference in Bunsin's height from the reference is calculated and it is marked as negative Y units. She asked the class to determine the difference in height between Azmi and Bungsin without directly measuring the value. The calculation of the height difference between Azmi and Bungsin is given below. The difference in electrode potential can also be calculated using the same method as in the previous situation. The electrodes with different electrical potential can be measured when we compare it with a standard electrode reference. In this topic, you will learn how the electrical potential of an electrode can be measured. When the concentration of the copper ion and zinc ions are both 1.0 molar, the cell voltage or electromotive force EMF of the Daniell cell is 1.10 watt at 25 degrees Celsius. This voltage must be related to the redox reaction. But how? In previous lesson, we can write the overall cell reaction as the sum of 2 half cell reactions. Hence, the measured EMF of the cell can be treated as the sum of the electrical potential of zinc and copper electrode. Therefore, the standard cell potential can be defined as the potential measured at a specific temperature, usually 298 Kelvin or 25 degrees Celsius, with all components in their standard states, 1 atm and 1.0 molar. In the other words, the standard cell potential is the sum of electrode potential of the 2 half cells making up the electrochemical cell. It is denoted as E0 cell. The electrical potential difference between the metal and its solution is known as electrode potential or half cell potential. Hence, the electrode potential can be defined as a measure of tendency of an electrode in a half cell to gain or lose electrons. Standard electrode potential is defined as the potential associated with a given half reaction with all components are in their standard state, 1 atm, 25 degrees Celsius, and 1.0 molar. Electrode potentials are denoted by the letter E, whereas standard electrode potential can be symbolized as E0. There are 2 types of electrode potential, oxidation potential and reduction potential. Oxidation potential is the tendency of an electrode to lose electrons or to get oxidized. Reduction potential is the tendency of an electrode to gain electrons or to get reduced. The half cell reactions are always written as reduction half reactions and their potentials are represented as reduction potentials. Standard reduction potential is defined as the potential associated with a reduction reaction at an electrode when all components are in their standard states. In Daniell cell, if one of the electrode potential is known, we can obtain the other by subtraction from 1.10 watts. If a potential value of a particular electrode is set at 0, the relative potential of the other electrode can be determined. For this reason, hydrogen electrode is used, which can serve as the reference electrode for measuring the potential of all other electrodes. Hydrogen electrode is made up a platinum electrode immersed in an aqueous solution of H plus ion 1.0 molar and bubble with hydrogen gas 1 atm at 25 degrees Celsius. The platinum electrode provides a surface on which the dissociation of hydrogen molecules can take place. The platinum electrode also serves as an electrical conductor to external circuit under standard state condition. The potential for the reduction of H plus ion is taken to be exactly zero. Thus, the standard reduction potential of hydrogen electrode is defined as zero. The hydrogen electrode is called the standard hydrogen electrode, She. The direction of half reaction on She depends on the other half cell connected on it. The She can be either a cathode or an anode. However, in both cases, E naught of She remains 0.0 watt.